Okay, we'll get started. So I'm Reese, if you didn't know that already. John Paxton is kind of facilitating an annual industry board meeting today, and so I'll be filling in for him today. And I always really enjoy the opportunities to kind of teach lectures, kind of like these I've done in the past. For me, like after grad school, I want to find a job that is like a computer science instructor or a teaching professor to teach undergraduate courses just like these. And so teaching is something that I really want to be good at, and so I really cherish these opportunities to help kind of get better for that. All right. Today, we are going to talk about assignment 4. We're going to get some feedback from you we're going to take a small survey, and then we're going to talk about a little more about functions today. By the way, if you were not here on Wednesday and you did not get your exam back, you'll have to talk to John on Monday, because I don't have them, and John doesn't have office hours today, I'm pretty sure, so you'll have to talk to him on Monday. All right, any questions about anything before we get started? Okay. So, assignment 4 is due tonight. I hope that doesn't come as a surprise. I know John didn't talk about this at all on Wednesday, but this has been on the course website for the entire semester. So I'll talk about this now. So due tonight at 11:58, and for this particular assignment, you do not need to do functions. You do not need to use functions. In fact, you shouldn't use functions. The main kind of construct that you'll be working with this, you'll be using loops. You'll be using for loops here, okay? So kind of what we have is kind of a Python file right here, and it prints out the lyrics from that really viral song and really annoying song from a few years ago, the What Does the Fox Say? And so what your job is to kind of take this file as a starting point, and you are going to try to eliminate all of these repeated words and repeated lines, and you're going to kind of remove that repetition with using for loops, okay? So, kind of how the grading is set up is there's 7 lines that have repeated words in them, right? So here is a line with repeated words. There's 3, 6, and then up here, don't forget about this one, there's 3 ow, ow, ows up there that you'll need to remove using or not really remove, but replace it with for loops, okay? And so, let's see, what else is there? And then also there are, two sets of consecutive lines that repeat. So we kind of have that chunk right there that repeats, and then that kind of chunk right there that also repeats. So you're going to have kind of multiple kind of for loops that you're going to be using in there. How this should work is that when you run your code with the for loops, it should print out the exact same thing as this, okay? Does that make sense? All right, and the grading is really pretty straightforward. It's just making sure you have all 7 lines taken care of. You have those 2 sets of lines handled for. The Python solution is easy, does not contain unnecessary code, and there's also just the lyrics print out exactly how they appear in the original file, excuse me. One thing I also want to kind of mention, because John does not really see the assignments. All of the feedback that you see on D2L and the grades you see on D2L, those are put in by Riley and I, okay? And there's a couple things I just want to address regarding kind of grading, kind of the grades you've received. The thing I'll say is that the grading rubric and the criteria is super straightforward, right? Every single assignment, you know what the points are for and what you probably would possibly be losing points on. I say this because on the assignments so far, I've had to take off points for things that were just really easily kind of addressed in the grading rubric. Like, for example, in assignment 3, when you were doing the wacky packages, like, there are people that forgot to include an appropriate comment that appears at the top of your file, okay? And so the Python comment is always going to be this. that comment should always appear at the top of any of your programs from here on out. It's just good to have your name on it, and also just provide a brief description on it. Sometimes it's not worth points on assignments, but you know, I've just seen I've had to take off points for a lot of really kind of dumb things that people just kind of forgot to do. So really, before you get started on the assignment and before you turn it in, please read the requirements. It's just kind of a checklist to make sure you got this, because I don't want to seem like a jerk for taking off, you know, 15 points for you know, for getting something really small. Well, I mean, we're just, you know, going through the grading rubric, and you know, I will say that the grading criteria is often really picky. I will admit that. Kind of like I saw on the exam, if you forgot a single space on the exam, or you left a space in there, you lost some points for that. I know it seems really dumb, but it's important that, you know, you try to match the sample output, the sample transcript exactly, because realistically, in the real world, and I hate to pull this card, but you know, if you're working for a software engineering company, and you know, the customer will always provide you with the requirements that they want for their project, and so it's important to always follow the requirements and make sure that you satisfy all kind of requirements set by the customer. Okay. Is there anything I'm missing, Riley? Have you seen anything that would be good to address now?
No, that's a really good point.
Yeah, I just want to address that now, and so hopefully, just because I kind of feel that it physically hurts me to take off an entire letter grade because you forgot a Python comment in there. That's just kind of how it is. Okay. Any questions on assignment 4 or about kind of the grades for the assignments so far? Okay. I'll give you a little bit of time today to work on assignment 4, so you don't have to spend the rest of your Friday doing that, because I'm sorry if you thought you didn't have anything due this week in this class, but you do. Okay. So the next thing is kind of on Wednesday, John kind of previewed this kind of like midway through the semester. We want to kind of get some feedback from you guys and kind of talk about what is going well for you, what's not going well for you, just kind of provide us some feedback so we can try to improve the course for the remainder of the semester, okay? So what we're going to do is we're going to take 5 minutes and just answer, all of you are going to answer just a few short questions, okay? So if you could all take out like a half sheet of paper, and if you don't have a half sheet of paper, I have some, just raise your hand. All right, so you're going to answer these 3 questions. The first is, what in the class is going well for you? What aspects of the course have been helpful for you? The second question is, what can be done differently? How can the course be improved? And the last one is there anything else you want to tell us? That's pretty open-ended, so if you have any feedback about anything, just put it down. Don't put your name down unless you want to. This won't be a grade. It's just feedback. John will read this. I will read this. Riley will probably read this too. So we're just gonna take 5 minutes and fill this out. Let me pause the recording. All right. So now we are gonna get into the kind of content that we're going to be talking about today, which is we're going to continue talking about functions. And so I'm going to just quickly change my font back to a slightly smaller size. Maybe that'll work. Okay, so recall that functions are a really important part of really any programming language that you do. From here on out, you'll probably see a function in like 90%. If you want to read them, you can. Oh, thanks. And so functions, right, were a way of how we can kind of link a certain block of code and associate it with a function name. And whenever we call that function, it will always run that code. And you can kind of loosely think of a function as kind of like a mathematical function where sometimes we have an input and sometimes we have an output. So like we saw last time, we had a function that calculated the area of a circle, I think it was. And so as an input, we gave it the radius, and the output, we got the area. And so sometimes functions don't have inputs, and sometimes they don't have outputs. It's not a requirement. It's just kind of how you design your code. Okay, so just as kind of like a warm-up, I guess, is, maybe let's just kind of write a function that will take in three numbers, three integers, and it's going to, it's just going to average them. So it's pretty straightforward, okay? And we're gonna write a function for that. All right. So the first thing is we have to define the function, which we do def, and maybe I'll make the font just a little bit bigger. Okay, I think that is good. I think cool. Thank you. Def stands for define, and then we got to give it the function name, and so maybe let's just call our function average num. All right, and then it's a function, so we have to give it our input parameters so the inputs that we're going to give this function. So for example, we're going to give it three numbers. So we'll give it a first number, a second number, and a third number. And so once we have all the inputs, we have to put a colon telling that's the end of the function definition, and we're going to get into our function body now. All right. So if we want to average those three numbers, and so if we give, if we give the numbers 3, 6, 9, we should get the average of 6, right? Because that will give us 18 divided by 3, 6. All right. So now we gotta, write our kind of code to actually calculate the average, and so, maybe we will, we have to return the average, and so let's make a variable that's going to represent our average, and we'll create a variable called answer, and we'll set it equal to number 1 plus number 2 plus number 3, and we're going to divide all that by 3. And then we're going to return our answer after we've calculated the average. Okay? Good so far? Does anybody see any issues? Yeah.
Parentheses around the addition.
Exactly. We need parentheses, right? Because we follow the order of operations. And so Python's going to see this division is going to do that first. And, we want to sum up all the numbers first. So we want to wrap all that in parentheses. Okay? Cool. So if you run this, let's see if we get our average. Okay, we don't get anything, right? And so I know this seems obvious, but I see so many people come to me asking for help because they're saying, oh, the function I've created, it's not printing out anything, it's not giving me the right answer, and for the most part, it's because they never actually call their function, right? We have the function definition, but to actually run that code that's in the body, we have to call the function. We have to invoke the function. All right? And that's why nothing's getting printed out. So if we say, let's go ahead and print our average num function, and let's pass in 3, 6, and 9. Okay? I'm not sure if you've kind of seen this before, but we can put our function calls inside of a print statement. And so whatever this function right there, whatever that returns, it's just going to print out whatever we get. Okay? And if we run this, we get 6.0. And one kind of weird thing is like, okay, we give 3 integers and everything divides evenly, so why are we getting a decimal, a float? And so when we do that division, Python will kind of cast our answer to a floating point number, which is good because sometimes our average might be a decimal. Okay? Any questions so far? Yeah? Now the beauty of this is that because we've kind of globalized the code for our average, we can now call that function as many times as we want, and we can just customize our input, and we can now just try a bunch of different numbers. And we can give, negative numbers. We can give, really big numbers. And our function will always take the input and do the exact same thing for every input. And so we don't have to copy and paste this code every single time for whenever we want to find an average. Okay? And we see that we get all of our different averages. Cool. So I'll get rid of that. And so in today's reading, which I'm sure we all did, it talked about local variables and function parameters, right? So function parameters or input parameters are these guys up here, okay? And so maybe instead of printing out kind of the answer or printing out the function, we could say, let's try to print out our answer. Let's just print out the answer down here, okay? Makes sense to me, as we have answer up here, and so let's just go ahead and print it out. The problem is that when we run this, we get an error saying that variable answer is not defined, okay? This is because answer is a local variable, okay? What that means is that it's a variable that only exists in a function, okay? And so in our function average num, that's where we create our new variable answer, right? And so it's only going to exist in this function, okay? And so down here, we're not in the function, so we can't access it because it doesn't exist outside the function. It only exists within the function. And it's the exact same thing for input parameters, right? And so if I run this, we're going to get the exact same error because our input parameters, number 1, number 2, number 3, they are only exist, their lifespan is only in our function average num, okay? And does that kind of make sense? It's just kind of an important kind of understanding of how variables are defined, and often this is called variable scope. And so you kind of think of it as like, looking through a scope, where does a variable exist within our program, okay? Kind of the next thing is it kind of works both ways. And so if I defined a variable, if we defined a variable maybe like right here, we called it var is equal to 4, okay? And let's try to print out var right here. If we run that now, we still get var still gets printed out even though it's not defined in the function because we defined var before our average num function. So remember, we kind of read this from top to bottom, and so var will get defined first and then our function, and so var will exist at that point, okay? But if I put it down here, let's see if that will work. It still works, and if we put it down here, we get an error now because we defined var after we kind of called our function, and so var doesn't exist until after we call the function. But the main idea I want to point out is that when you define a variable inside of a function, you're not going to be able to access that function whenever you're outside the function for the most part. And so like if I had like an average number 2 function and maybe there's no input, and I just define a variable called foo and I set it equal to CSCI 107, okay? And if I try to print out foo right here, and let's get rid of this line or else we're going to get an error, and we run it, we get an error message now when we try to print out foo in that second function because foo is only defined in our average number 2 function, and those two functions cannot see each other, they can't communicate with each other. They can only see what's kind of in the function and what's been defined before the function has been called. Okay? So that's kind of the main idea behind local variables. Does that make sense? All right. If we wanted to simplify this, we could just copy and paste like our calculation, and let's just return our calculation instead. So we just kind of remove just one kind of redundant step. Maybe I wouldn't say it's redundant, but we've cut our lines of code in half. And so what it's going to do is it's going to calculate number 1 plus number 2 plus number 3 divided by 3 first, and whatever that calculates to be, it's going to return that value. Okay. Any questions so far on this? Cool. All right. We are going to work on one of the kind of class activity examples for today. And so we're going to do this a little bit backwards. We are going to do exercise 13, and then we're going to do 7 as active learning. Okay. So what we're going to do is we are going to write a function called sum2. What it's going to do is it's going to return the sum of all the integers up to and including n, and we're going to use something called the accumulator pattern, which is something I was in the reading for today. And so, what this is going to be is that if we plug in, or if we use 3 as an input to this function, it's going to calculate 3 plus 2 plus 1. If we give it 10, it's going to do 1 plus 2 plus 3 plus 4 plus 5 plus 9 plus 10. That's kind of the idea here. Okay? So I'm going to comment what we did here, and we'll get started on kind of the new function that we're making. Okay? So the first thing we do is actually need to define our function that was called sum2, and it told us that we give it an input n, so like the number that we want to sum up to, including, and so that's the only input, right? So we're done with our function definition, and so now we need to write the code that will actually sum up all of the numbers to get our answer. Okay? And we're going to use the accumulator pattern. All right? The accumulator pattern is a really fancy name for doing something that's really not that fancy. However, it's a really important topic to understand because you do this a lot. Like in the next Python class in CSCI 127, we do this all the time. All right? So what we want to do is we're going to use the accumulator pattern, which means we're going to use an accumulator variable. Okay? What this accumulator variable is going to do is it's going to, over the course of running our program, it's going to kind of progressively keep building up on a variable until we're done with some iteration, and then by the end we'll have a full built up kind of sum or value. All right? So if we're using accumulator, we always need to, we'll call our accumulator variable answer, because that's going to be our sum at the very end that we're going to return. Okay, we always need to initialize it first, okay, and for the most part we're always going to initialize it at 0 because we're going to start counting at 0. And so what we want to do now, as I'm kind of flying through this, but I'll make sure we understand this when I'm done, is we want to iterate through all the numbers from 1 to n and sum them all up. So we're going to take 1 plus 2 plus 3 plus 4 plus 5 all the way including n. Okay? So we want to do a for loop, so we can say for number in range, and we want to kind of iterate through the set of all the numbers up to n, right? So if n is 10, we're going to loop through this 10 times, okay? And so here's the tricky part with the accumulator pattern. Okay, so what I'm going to do is I'm going to update our accumulator variable, and I'm going to set it equal to its current value and add on the number that we're currently kind of iterating on, okay? I hope this isn't super tricky, okay? So we're going to take the current answer, and we're going to add on our number, and we're going to store that inside of that same variable, okay? And so hopefully you can see that as we progressively loop through, we're going to add on 0, and then we're going to add on 1, and then we're going to add on 2, and then 3, and then 4, and then 5, and then 6. And then by the end, we're going to have a finished sum of our values, okay? And when we're done with that, I guess I'll make a note here. This is the accumulator kind of step. Hopefully I probably didn't spell that right. And we're going to return our answer at the very end. Okay? Any questions on this so far? We'll go through it one more time, but I just want to quickly check in. Okay, and so now let's let's kind of call our function. So let's try to print sum2, and let's plug in 10 for our value, and let's see what happens. Okay, so if we run 10, we get 45, which is not the right answer. When we plug in 10, we should get 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, which actually sums up to 55 if you do the math. And so we have some kind of issue with our code. And this is one of the hard parts of computer science, is when your code is not working as you intend it to be, and it doesn't give you an error like it did up here. You have to figure it out on your own. Your code compiles kind of fine. There's no kind of syntax errors, but kind of logically, there's something going on that's not getting kind of the answer that you want. Okay? And so like, okay, what do I do? It's like, how do I even start going about debugging my program? The thing I would do is I always try to print out the values. So like, in this case, like we're not summing up to the correct value. We're always a little bit short. So maybe let's try to print out number and make sure we're adding on the right value. So if we come up here and we print number in our for loop, we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because those are the numbers we want to add on, right? If we run this, we start at 0, right? When we print out number, we start printing at 0, and we only go up to 9. And so 10 never gets added on, so it makes sense, right? Why we're 10 short. And even if we changed 10 to 11, we should now get 55. Okay? So what's going on is we're not correctly getting our very last number, right? Because it should be including n as the kind of top sum. So this is because our for loop, our range function, will start at 0, and it goes up to n, but it actually doesn't include n. So 10 never gets added on. Okay? So what we can do is we can modify our range, and I don't remember if John talked about this already, but when we do a for loop using range, you notice that Python kind of gives us a hint about what we can do with range. We can give it a start, a stop, and a step. You don't worry about step, but realize we can give it a starting point and a stopping point. Okay? So it's like, we don't want to start at 0, right? Because it doesn't make sense adding on 0. So let's just start at 1. We'll always just start adding on 1 first. And we want to go all the way up to n plus 1. Okay? N plus 1, right? Because the stopping point does not get included in the range, and so we have to go 1 beyond it so that it'll actually get included. Does that make sense? Okay? So you have to do n plus 1 to actually get the last number. Now if we run this, we get 55, like we normally should. Okay? And so I'll get rid of this print line now that we've successfully kind of debugged our program. And so the accumulator pattern, right, is just a way of how over time we can have like a running tally or a running sum and kind of accumulate a value over time, over the kind of length of our program. And so so I'm just going to kind of run through just kind of how this is working. So in our first kind of loop through our program, we start off at 0, right? We initialize answer to be 0, and then we add on 1, okay? And then we're going to loop back, and now our answer will be 1, and now we're adding on 2, okay? And then we do 3 plus 3, and then we get 6 plus 4, and then we get 10 plus 5, and then all the way until we get to the very ending point, which we have 45 plus 10, and we get our answer. Okay, so that's kind of illustrating kind of step by step what's kind of going on with that accumulator. Is we save our value, or we take the current value of it, we add on a number, and we save it to that same variable, and then we do the same thing. We keep building on and building on and building on, and progressively kind of saving our value, adding on to it. Does that make sense? Cool. It's a little bit confusing to explain, but I think you should get some practice with it over the course of the semester. And so now as we can kind of, test out our code. It's important to test out your code and make sure everything is working as intended. And so, let's try to put, 50, 55 in there. And maybe let's try a really big number, so like 1,000,000. And, it should work. It's going to be a lot of steps, but eventually, right, our computer runs so fast that you really don't see any of the time behind what's going on. All right, so we get 55, 1540, and looks like 1,000,000. If you sum two, it gets 5 trillion. I don't know. Cool. Any questions on this? Cool. All right. So we're going to do a little bit of active learning right now, and I'm going to have you guys do number 7, which is extremely similar to this. It's the exact same function, so you'll define like a new function. Obviously, since we have a function already called sum2, you'll have to make a function called like sum to the number 2, just to show that it's a different function. One more thing that I want to mention, because I know people will probably run to it at some point. If you define a function called sum2, 2, for example, like what we're going to do now, if we run this, Python's going to kind of yell at us because we can't define a function and not have anything in the body. Python makes the assumption that if we're going to define a function, we're actually going to put something in that function, right? So you can't have empty functions because there needs to be something in the function to run. And even if it's just one line, Python's not going to yell at you. Okay? The other thing, because I know people are going to do this, and it physically breaks me when I see people do this, is when they define a function inside of another function. Okay? Python doesn't give you an error for this, but this is horrible to do this. You should never define a function inside of another function, because functions should be independent from each other and they shouldn't live inside of each other. They should be on their own kind of separate, spaces. It works, but it's horrible practice. You will never see a function inside of a function, and for the most part. And so, to be honest, if I saw somebody put a function inside of a function inside the program, I'd probably take off a few points for, unnecessary code or an elegant solution. Okay, that's one thing I wanted to mention. All right, sorry, that was kind of a random tangent I went on, but okay. So we're writing that second function sum2, which has the same thing, but this time we use this really nice equation that calculates the summation for us. So we take, our n value, we multiply it by n plus 1, then we divide everything by 2. So like, for example, we take 10 times 11, so we get 110, we divide by 2, we get 55. So it works out every time. Okay? This is pretty easy. It's pretty similar to what we did last time. So we're going to do a little bit of active learning, where you're going to solve this problem. The function that's going to take in an n, it's going to output our answer using that formula. Okay? If you want to take this time and work on assignment 4, that's fine with me. I won't get mad. You can do whatever you want if you think this is easy. If you want to work on assignment 4 for the next 10 minutes, that is fine. Okay? But I'll let you loose and work on this. If you have any questions, let Riley or I know. Zoom recording. And so let's define sum2 2, and we're going to pass in the same n. But this time, all we're going to do is just return kind of the function that was given to us. So n plus 1, and then we'll divide all of that by 2. And to verify that's working, we will run this. And we should see that we get the exact same answer each time. So we get 55, 55.0. Remember, it turns it to be a float because we're doing division. And so it makes sense that, like, if we're summing up numbers, we're always going to get an integer, right? So if we wanted to keep it consistent, we could just cast it to be an integer. That way we're getting a whole number. Okay. Any questions on that? All right, that's all I got. Thank you so much for showing up today. And have a great weekend. I'll see you on Monday.